Hey physicists, what's the crack? So today we're going to do some questions on the types of error, okay? Because recently in the papers this come up a lot more because now they've been given the data sheets, okay? So the two main types of error that you need to know about is systematic error and random error, okay? The way to remember random error is it's always something to do with the human, okay? So it's always something to do with you, something that you've done wrong. Whereas a systematic error is a problem with the system, okay? It's a problem with any equipment that you've used. So a systematic is always to do with the equipment, okay? So the main one for a systematic error is something to do with a zero error, okay? Or that the equipment is not being calibrated properly. Okay, so for example, let's say I have a thermometer and my thermometer is supposed to tell me that this room right now is sitting at 25 degrees Celsius, okay? So then if I was to put my thermometer inside water, the temperature will start at 25 and lower raise based on that number. But maybe my thermometer is off. Maybe even though the room is at 25, the thermometer might say 30 degrees Celsius, so my thermometer isn't calibrated right. So when I go to measure the temperature of different things, the temperature will always be off no matter how well I take my readings. Okay, so it's an example of your systematic error. Remember, your random error is something that you have done wrong. So something that I could have done wrong is if I'm ever recording the time. So say people are doing a running race and I record the time of these people passing the finish line. If I get distracted and don't hit my timer in time, then the time that I've recorded for them to run might be too high. So again, the random error is something to do with you because again, it could be because you got distracted and mostly that comes up in timing, okay? Other things you could have done wrong is like we go back to our thermometer, okay? So say I want to read the temperature of that thermometer. When I do that, I need to go to eye level, okay? And if you're not at eye level, that's called a parallax error. So a parallax error is because instead of me dropping down to eye level to read that thermometer, I said, okay, I'm going to stand up tall and try to read my thermometer from up here. So when you try to read the number from up here, you're always going to get a number that's off, okay? So a parallax error is because you didn't read it from eye level, which you always should do. And again, just to go back to the zero error one, a zero error one normally comes up in balances. So we take the mass of things. So for example, if I went home today and I wanted to weigh myself to see what my mass is, okay, I'm not going to step on the scales if it already says 0.2 because clearly it's going to weigh myself too high. I'm only going to get in the scales and I touch it to calibrate it if it says 0.0, okay? So when you take measurements, you always need to make sure before you get on them, they say 0 or all of your readings will be off all the time. So that one is your zero error. So that's right.